Hi guys, this is Mansi Varde and I am going to tell you about the rolling LCD display. So to get started, let's first look at the pin diagram. This is an LCD. It is a 16x2 LCD because it has 16 columns and 2 rows. So we say this is a 16x2 character LCD. So as you can see the pins, I am going to group the pins in certain types. So the first type will be the power pins. The VSS, VDD and VE. They form the power pins. The power supply that is to be given to the LCD are given through these pins. Next is the control pins. So what does control pins do? Whether you want to write or read, if you have enabled the LCD or no, which resistor you have select. So all the controlling actions of the LCD are taken place through these control pins. After control pins, we have the data pins. We have 8 data pins, which means we can send 8 bits of data all at the same time. That is, we can send 1 byte to the LCD at once. After this, we have 2 pins, which is the backlight anode and the backlight cathode. Well, they are just to light up a small LED which is present. We are not going to use it, so let's not worry about it. Next, let's take a look at the power pins. First of the power pins is the VSS. VSS is the ground pin. So this particular pin is supposed to be grounded. On our 16x2 LCD, the VSS pin will go to the ground of the Embed board. Next is the VDD pin. Now, the VDD pin. Previously, when we connected our peripherals, we connected it to a 3.3 volt supply. But most of the LCDs work either on a 5 volt or a 12 volt supply. The LCD which we are using will work on a power supply of 5 volt. Thus, we will be connecting the VDD pin to the 5 volt output supply pin. Next, we have the VEE pin, which is known as a contrast pin. Now, what exactly is contrast? Consider this example. See, you find something as a background. The light green color thing is the background and the foreground, that is what is written. This is a 16x2 line LCD display. All that written material is the foreground. The difference between the background and the foreground is the contrast. The VE pin actually determines how much should the contrast be, how much should the difference be between the background and foreground. Usually it is connected to a pot, a potentiometer, whose one end is connected to ground and other is connected to VDD. But now we are going to connect VEE to ground, because VE connecting to ground would mean full contrast. Thus we have these pins. So as you can see on the left side, what you see is the pins of the embed, that is ground connected to VSS of LCD, pin 5E underscore USB of the embed connected to the VDD of the character LCD, ground connected to the VEE. Let's move further to control pins. We have 3 control pins. First is RS, which is register select, the instruction register and the data register. When we give a 0 to the register select, the instruction register is selected, and when we give a 1, the data register is selected. Now, what is the function of this instruction register and a data register? Instruction register will determine, say, the position of the cursor, where you want to write, how you want to write. That is, the instructions given to the LCD are to be controlled by the instruction register. And what is the data register? Data register is a place where we will be sending the data which we want to display. Every alphabet or every character, since it is a character LCD, every character which we will be sending will be in the ASCII format. Now, the ASCII representation is 8-bit and as we saw earlier in the pin diagram, we have 8 data bits. So both the instruction and the data both go through the 8 data pins which we saw, D0 to D7, but the register select decides to which register is the data which is sent is stored, either to the instruction register or the data register. Next we have the read write. The read write pins is because read is for reading the data from LCD or write for writing the data. It is actually write bar. Since we'll always write to LCD and never read from the LCD, we will be connecting this particular pin to ground. Next pin we have the enable pin. So enable is to check, or I would say enable is to enable the LCD. Now let's just take a look where all these pins will be connected on our Embed board. So RS will be connected to a pin PTC9. Why it will be connected there, I'll show you in the code. Read write will be connected to ground. The reason for that will be we are going to write to the LCD and not read from the LCD. And enable will also be connected to a pin number PTC8, which I'll tell you in the code itself, because these are going to be the programmable pins and we are going to give a high-low, alternate high-low depending on what we want to do. So let's take an example of the register select. It cannot be 1 forever nor can it be 0 forever, because when we start writing, initially we will define a cursor position. So that information has to be passed to the instruction register. Then what we want to write, our actual data, will be passed to the data register. So the register select has to go 0. That is why these pins are connected to the embed boards which keep on altering. Now we have data pins. What were the data pins? D0 to D7. So D7 forms the MSB and D0 forms the LSB of the data pins. So I just split them up into a higher nibble, which is D7 to D4, and a lower nibble, which is D3 to D0. A nibble is a 4-bit number. As I said earlier, we have to send ASCII values, that is 8-bit values. So it looks logical that we are going to use all the 8 pins, isn't it? But there is a provision for our LCD that instead of using all 8, we can use only 4 of them. Now why would one do that? Now let's take the example of serial and parallel communication. What do you think is the advantage of serial over parallel? Less number of wires, and disadvantage would be it is slower. So in our case, I won't really say that this is serial and parallel, but if you use a 4-bit mode, a 4-bit data transfer mode, then your communication might be a bit slow, but you will be saving a lot on your pins. And for our application, we won't really need 8 wires. So we are going to use the higher nibble for communicating, and it will be connected to the following pins: PTA5, PTA4, PTA12, PTD4. Why they are connected? Again, I'll let you know in the code. So now let's move on to making the connections. Okay guys, so before making the connections, let us write the code. So what do? We click on new and name it as rolling display. Okay, and say okay. Now first we'll write a code. Let's understand what the code does, and then we will move on to making the connections. So we are going to use LCD, so we will need one particular class, a library of the LCD itself. So what do? We add one. How do we add? We click on import and then type text LCD and hit the search button. When you search, you'll get certain options. Make sure you type T capital and LCD capital, remaining letters small. If you have typed in the same manner, you will find Simon Ford library present. The author is Simon Ford. So just select the library and click on import. While importing, make sure keep the name as text LCD itself and import in your particular program. After this, let's go type the main code. Now, instead of this, I have the code written, so I'll just copy paste it. The first line is embed, including embed.h library. In the second line, we are including the text LCD library. Now, as we know about the class, object and variable type, so text LCD is the class, LCD is the object, and these are the pins. Now let's see how it is written. There are a certain number of pins defined. After the pins, it is written text LCD : 16 cross 2, since it is a 16 cross 2 display. Now let's just go to the classes here and click on text LCD. You'll find a reference. Now come down to this particular constructor and destructor documentation. See what you find here. This is how it is written. So the first pin is RS. This is how we have defined, right? Text LCD, some pins, and then you've written LCD type, that is LCD 16 cross 2. So we have the first pin RS, second one is enable, then the remaining 4 pins are data pins, which is D4 to D7, since we are sending data to the higher byte. Come back to the main code and check. This is PTA1, which is RS. That is what we've defined earlier. That is, I defined in the video explanation. Then we have our enable. Then we have the 4 data. Okay, now let's move on to writing the main code. Now, the main code, we have defined an integer row, which is 2, since we have 2 rows. Integer column, which is 16, since we have 16 columns. And 2 integers I and j. Now inside our while one, we have a nested for loop. One for will take care of the row and the other one will take care of the column. Okay, then these are the functions which are related to the class LCD. So what do we have? LCD.locate j, I. Now j is for column and I is for row. So LCD.locate is a function which will set the cursor to the position which is given in the brackets. So we are saying locate the LCD, locate my cursor to column, row, and we are passing the column and row value which is going to be changed. Thus we have our display rolling. Then we have a function printf. Now this printf is not of the class serial. This printf function belongs to the class LCD. Belongs to the class text LCD whose object is LCD. So this printf belongs to the class text LCD. So whatever we write here in these codes will be printed on the LCD. After saying print, we say wait. Wait for 1 second. Now, if you don't have that wait, it will just keep running and you won't be able to see. After wait, we have LCD.clearScreen. What does CLS do? CLS is clear screen. It will just clear away the entire screen, the contents of the screen. and then lcd.printf will write again, since this all is in a for loop and the entire structure is in an infinite while loop. So now let's just make the connection, dump the code and check what happens. So let's start making our connections. Here we have our embed board and this is our LCD screen. Now first what we'll do, we'll make the connections for the LCD. So here as you can see, what do we have? We have VSS, VCC, VE. All the pins that I showed you in the video are written here, so you can just scan through them. Now let's just make the connections. So VSS first goes to ground. So I'll take a black wire and I'll connect it. Then I have VCC. So I'll take a red connection. For now I'm just taking wires out of my LCD screen. Okay. Then I have VEE. VEE also goes to ground. So I'll take a black wire again and I'll make a connection. So basically what am I doing? Whichever wire is going to ground, I'm just putting it the color black. Then I have after VE RS. RS is register select. Now that is a control wire. So I'll use a different color. I'll use yellow. RW. RW is read write. So that will be going to ground again. I'll use a black wire. Okay. After RSRW we have enable. For enable I'll use a brown wire. After enable we have, as you can see here, DB0, DB1, DB2, DB3, DB4 up to DB7, and then we have LED plus and minus. We are not going to connect the last two, that is LED plus and minus, but we are going to connect DB4 to DB7. So I'm going to use green color wires for that. So this is my DB0. Then I have 1, 2, 3, 4. Yes. So this goes here and the subsequent pins. Okay, so as you can see, I've made the connections for my LCD. Now I'll make the connection to my embed board. So when you make connections to your embed board, make sure that the embed board is not connected to your PC. That is, it is not powered. The board shouldn't be powered when you make the connections. Okay, so now we are going to hold our board like this, and let's see in the card here we have named from PTA 1 and so on. So these pins are the ones which we are going to use, and they are in the same order. But first what we'll do, I'll just connect the ground pins to ground. So for reference I'll just see and connect them. So first two grounds are here. One, two, and the third one is on the left side, on this side. So as you can see, it's here, pin 14, which happens to be the fourth pin from down. So it's like 1, 2, 3, 4. Yes. Then we connect our VCC. We will be connecting it to P5V USB, which is here. Okay. So till now we've done this. Then let us connect the control pins. Now enable is my yellow, and then I have my RS. So we have RS connected to PTA1, and our RS pin is nothing but yellow. So I have yellow connected to PTA1. Then enable connected to the next one. So let me just take it out, and it's connected here. Then I have D4 to D7 connected in that order. So I just take one by one and connect them. Okay, so I'm done with the connections, as you can see. Now what I'll do, I'll program my embed board, and let's check the output on our LCD screen. Okay, so now the code is loaded inside, and I'll just reset my board once, and there you have the hello is being rolled. So this is rolling display.